My mic was muted. Not bad. Anyways, happy Thursday. But it might not be so happy for some of you because you just wrote your paper 1. And what I've heard from the internet and my own kids is it was really difficult. But I feel like they say that every year. And I've been doing the past like 5 years worth of exams and they're never that bad in retrospect. So I don't know. But tomorrow is paper 2. So today is a little paper 2 extravaganza. I can finish a paper 2 in about half an hour, I think. Or was it 40 minutes or so? So I'm going to try to fit 2 to 3 of these in. And we're going to start with May 2017 time zone 2. I think last stream I did time zone 1. And I don't know. I can't predict the future, so I'm not going to know what's on this exam. So this is the best that we have in terms of preparation. Doing a bunch of old questions. So what do we got? We got circle, radius, center. Hey Snake Star, just the person I wanted to talk to. How's your paper 1? And then let's see, find the length of arc ABC. So find this arc length, that's easy enough. We have a formula for it. Arc length, I'm just gonna call it S. And hello serpent is the angle in radians times the radius. In other words, this arc length should be 1.9 times 40. But as I was saying earlier, I was checking out the IBO subreddit and people are losing it over today's math paper. Like, apparently like the last question was crazy. Like something to do with like a bunch of probability, like all over the place. Like my kid, who I predicted as a 7, like he should be getting a 7 easily. Even he said like it was slightly more difficult than he expected, which is not a good sign. But on the flip side, it was only 1 or 2 questions they said that were very difficult, and they said that the rest weren't actually that bad. Yeah, the last one, it was messed up. I don't know. I haven't gotten to see it yet. My coordinator will give me a copy of it soon. So I don't know if there's like an embargo on it, because I kind of want to do it on stream. But I feel like you know, the IB hitmen are gonna get me if I do that within like the near future. But whatever. I'll double check with my coordinator and see what the rules are. And then next is find the perimeter of the sector. So find this perimeter. That's easy enough. We found the arc length, and then we just need to add these 2 sides. So 79 plus 40 plus 40. 24 hours? Okay. So that's pretty good content for Sunday then. Because that'll be, you know, 24 hours after both papers at least. So maybe I'll go through both of them or one of them. We'll see. So 79 plus 40 plus 40 was 159. It should be my perimeter. And then we need to find the area. Area is easy as well. There's a formula, 1/2 theta times radius squared. We know what all of these values are. So 0.5 times 1.9 times 40 squared. So 1,520. So easy peasy. I mean, it's question 1. They're trying to give you some free marks. So let's check the answer key before I move on, in case I messed up somewhere. So 76, 156, 1520. So looking good. And then I feel like this is going to definitely be a thing. Linear regression, because it's the only really appropriate paper to ask a linear regression, because they're not going to ask you that on paper 1. That's kind of weird. So you can, I would say, expect a linear regression question. There's almost always one. But if there isn't, well, like I said, I can't predict the future. Do you get money from me watching the ad? Yeah, I think so. Thanks. But anyways, we're going to do a linear regression of n on t. So let's just go to our lists and clear out these old ones. And then we're going to do 4, 5, 17, 31, 29, 11. And then 24, 26, 36, 38, 46, 28. So once it's here, we can go to Stat, and then move over to the Calculate menu, and then go to Linear Regression, which is number 4. And then my X list is the T variable. So list 1, list 2, I don't have a frequency list, so clear that out. And we can calculate. So there's my A, there's my B, 0.667, and then 22.2. And then write down the correlation coefficient, which is 0.923. Then we use the equation to estimate the temperature, estimate the visitors when the temperature is 15. Okay, so we just literally plug in 15 for t and then calculate out n. So let's do that. 0.667 times 15 plus 22.2 gives me 32.2. Now, do they want me to round this to the nearest person because it's about visitors, or do they want me to keep it? Let's see. So here you go, 0.667, 222, correlation coefficient 923, and then, aha, so you see, because we are talking about visitors, we have to round down. Must be an integer, so you're gonna lose a mark if you don't do that. Oh well, okay, moving on. This looks like a paper 1 for some reason. So we just have this function defined from -6 to 2 like this, and then you have points here and here, and then there's a minimum right here. Okay, then we have write the range of f, so that's easy enough. The range is literally just from 6 to 0. So we can just say that. And then we have a function g, which is a transformation of f. So this means that it goes to the right 5 spaces. So let's just move this over 5 spaces. Where does this go? This one's 2, so it goes to 3. So there's g, 5 spaces to the right. Pretty easy. And then write the domain of g. Well, all we do is we move the domain 5 points to the right. or you can even just look at your graph. Either way, the domain is -1 to 3. Wow, this paper is pretty easy so far. But I've noticed that paper 2s are time zone 2's papers are slightly easier than time zone 1's. So maybe this is just going to be overall easier. So we have water in a port, follow some cosine function. Sure. And then at high tide, the depth is 9.7. And then at low tide, which is 7 hours later, the depth is 5.3. So at high tide, we have a maximum depth of 9.7, minimum depth of 5.3. Now, this is kind of an odd one. I've seen some students get tripped up before because this is talking about water depth. So you would think that 9.7 would be lower, but it's just the way that you orient your numbers. Just remember that this is talking about the depth of water. So obviously 9.7 means that you have a deeper, I guess, whatever you would call it, tide. And then it says 7 hours later. So the time from high tide to low tide is 7 hours. And then, as I said before, the time from maximum to minimum is always half a period. So right there, we already know that our period is 14. And then this is 2 pi over Q, which is your horizontal compression. So in other words, Q is going to be 2 pi over 14, which is pi over 7. Now, it tells you right here that you have a vertical translation of 7.5. So 7.5 is right in the middle of your maximum and minimum. So what we can do is we can find the amplitude. And the amplitude is just the difference between the middle and the maximum or the minimum. So what is that? 2.2? So P is related to 2.2. It's not quite 2.2 necessarily. It could be. It doesn't have to be, because you need to decide whether or not it's positive or negative. Now, if you notice, T represents the number of hours after the high tide. So at the beginning, we have the high tide, so it starts up here. So that's good for a positive cosine graph, because cosine graphs need to start at the maximum, which means that this is definitely positive. And then use the depth to find the water after 10 hours after high tide. So now that we know our function, it's 2.2 cosine pi over 7. And then we just plug in 10 plus 7.5. So punch this into a calculator. How is this pi over 7? The time it takes to go from high tide to low tide is 7 hours. So that's half the period. It's 14. So the period can also be calculated by taking 2 pi and then dividing it by Q, because that's being multiplied by T inside the cosine. So then you just do a little switchy. So Q is 2 pi over 14, which reduces to pi over 7. And then you punch this in the calculator and you should get your answer. Again, just make sure that you're in radian mode. Otherwise, you will get the wrong answer. I'm a little too lazy right now, so I'm just going to check the answer and see what that is. Oh yeah, and I forgot to check my answer for the previous one, but that one was pretty easy. Okay, 2.2 as you see, and then pi over 7, and then you see they plug in 10. and then they're going to get an answer of 7.01. 7.01. And just in time, Bolt Lightning says that recommends that I stretch, but I gotta go to the washroom, so I'm actually gonna take a tiny little break. I'll be back. Okay, I'm back. Hello, hello. I also got water. But anyways, so far so good, although I'm a little slow today. It's been 20 minutes already. Yeah, I did stretch when I got up. And then let's see. Oh, here's a nice and easy one. So we have a geometric sequence. First term is 768. And then the second term is 576. Now it says here, find the least value of n such that the nth term in the sequence is less than 7. So what we're going to do is we should immediately try to find the common ratio. So we're just going to take the second term and then divide by the first term. So 576 divided by 768, which is 0.75. Okay, that's a nice number. Now what it says is we need to find the least value of n is a whole number, so that the next term in the sequence is going to be less than 7. So this thing is decreasing each time because you're multiplying by 0.75. So the general term, un, is the first term times the ratio to the power of n minus 1. This is just from your formula booklet. Now we want to find out when this sequence is less than 7. How come you divide the second term by the first term? Because this is a geometric sequence, so to get the second term, we would multiply by r. But because I know these two, and I want to find r, then I would take this one, and then I would divide by this one. It's like, 10 becomes 5, so what did you multiply by? Well, then you just take 5 divided by 10, which is 1/2, which makes sense, because 10 times 1/2 is 5. Okay, what's next? So we should find out when this is actually equal to 7, and it might not actually be equal to 7 during the sequence. But what it's going to tell us is it's going to tell us what exponent it would be, what n should be if it could equal 7. It's going to be probably a decimal. And then what we do is we just round up to the next whole number, because n is like a term, so you can't have like half a term. So from here, there's lots of ways to do this. We can solve it using logarithms. You can solve it using graphing. Let's do logarithms. So first, I'm going to isolate my power. So I'm going to divide the 7 by 768. So that goes over there. And that's going to get you something. I'm just going to leave it as a fraction. That's kind of ugly. And then to solve for our exponents, we convert this to log form. So this says log base 0.75 of 7 over 768 should be equal to n minus 1. And then this we can calculate in a graphing calculator. Mine is lucky enough to be able to choose my base. So I want base 0.75, and then this is the log of 7 over 768. So you press enter, and then this is going to be 16.33. So that means that n is 17.33. And then again, we round up to the next whole number. Because if we round down, because n has to be a whole number, if we round down, then it's not going to be small enough. It's going to end up being bigger than 7. So round up to 18. So let's see if that's what they do. Yeah, so they do the log, and then you can see you get 17.33, but n has to be an integer, and we want it to be smaller than 7, and we know that each time we multiply it gets smaller, so we round up from 17.33 to 18. This also seems like a paper 1 type question, but whatever. Okay, f is some function, g is another, and then we're going to form a composition, f of g of x. So f of g of x means that we take g and we plug it in for x in f. Plug g into f, essentially. So what does that mean? That means that I'm going to have x squared minus 2 squared minus 1. And then I'm sure if you expand it out, you'll get this. I mean, it's not that hard to see. This will end up being this. So I'm going to just save myself a little bit of time. Just multiply this out and you'll get here. Then we need to sketch this graph from 0 to 2.25. Sure, okay, whatever. We have a graphing calculator, so I'm just going to put it in and graph it myself. Well, not myself, but graph it here. So x to the power of 4 minus 4x to the power of 2 plus 3. And then I'm going to change my window to kind of match their window. So they have it going to 10 and negative 2. So negative 2 to 10. Oh wait, no, this is my x values. My x values, they tell me, is here, 0 to 2.25. And then when I graph this, here it is. So it starts up at 1, 2, 3. And then it goes to some amount, and then I don't know how accurate they want this. Hey Tofu, how's it going? Like, do they want me to be accurate with my x-intercepts? It does say sketch though. But just in case, let's calculate the x-intercepts. So I'm going to press second, trace, calculate the 0. So left bound, right bound, guess. Okay, there's a 0 at 1. And then there's a 0 somewhere else. How's work today? It was alright. Tried to teach. Okay. So I kind of have this imbalance with my grade 8s. My morning class basically doesn't know integers. They never learned them in elementary school. And then my PM class, most of them basically knew integers already. So it was kind of weird because I had to I want to keep them synchronized, but the morning class is, yeah. The morning class had a little bit of trouble, so we're going to spend more time on it tomorrow. And then the afternoon class, I don't know. So the second x-intercept is at 1.7. So I don't know. I'm going to just somewhere here, I guess. Yeah, don't ask me. Elementary school, they do whatever. They just let it rock. And then it goes like this. And again, I don't know how accurate they want this. I guess the answer key will tell me what they're looking for. And then it says here, oh, this one is, I've seen this type of question before. It's a very odd question that you need to understand what it's really asking. Okay, this equation has, when it's equal to k, so we don't know what k is, it should have exactly 2 solutions in this domain. And then we need to find the possible values of k. Did I play spike ball today? No. Did you take a look outside for the past like 3 hours? It was like torrential rain. So k is a value for the function, the y value. So as you can see, if my k value was 7, I have 1 solution. So it's essentially saying what y values will I go through the graph twice. So starting here, which was at 3, and then essentially all the way down to, except for the bottom part here. And then, so if your k value is in between this range, you will be intersecting the graph twice. So you will have 2 solutions for this equation. Now we need to find out how low it can go. So that's the minimum. So I guess we'll go here and calculate the minimum. You're asleep from 1 to 4? It was raining after 4. So I'm just calculating the minimum, which is at, it's kind of blocking it, but I think that says -1. So find the possible values of k. So k can be equal to or less than 3, but it's strictly greater than 1. You can't do the equality because when it's equal to 1, it goes through the graph once. So equal to 3 up to -1 or vice versa. Okay, time to see this. I want to see what they're looking for. So this one was straightforward, and then here's how the marks are rewarded. You get a mark if it's the right shape. So as long as you drew it the right shape, you get a mark. You get a mark if you have a left hand endpoint, so here, and you have a right hand here. And you also have a minimum here. So I guess we did that. And then as you can see, here's your k values, right? Strictly greater than -1, but less than or equal to 3. I don't know. It's raining all week for the next couple of days at least. So no spike ball for the immediate future, which is kind of sad. Okay, on this question, distance is meters and times seconds, yeah, whatever. Okay, we have a velocity graph. And then here's the function for it. We have some intercepts here and here. Now it says find the maximum distance of the particle in this time and justify your answer. So maximum distance, right? This means that your distance derivative, which is actually the velocity, is equal to 0. And we already know where the velocity is equal to 0. Here and here. But we want a maximum. So a maximum happens when you have it 0 at your position or your time, I guess in this case 2. But it needs to be increasing first, and then it hits 0, and then it decreases. So in other words, you need your velocity or you need your velocity to be positive and then negative. In other words, 2 is a minimum because you have a negative velocity and then you switch to positive velocity. But we want positive velocity and then negative velocity. Wait, am I doing this right? I think I'm messing this up. Okay, never mind. Maximum distance means you take the derivative of distance. Derivative of distance or displacement is velocity. So would the maximum distance be here? But there's, because this kind of matches, it's negative on the right side, but it's like nothing on the left. I mean, we could also... So, I don't know if they changed this from IB curriculum, but you also need to check the endpoints if that's the case. So we should also check the endpoints at time equals 0, because I know this is also equal to 0, the derivative here, but there's nothing on this side. So you can't say anything about the critical point. Now the issue is, of course, we have the velocity, so you can't just plug in 5 into a distance formula because you don't have it. Alright, so let's see what this is all about. And this one's not particularly nice to take an integral of to get the distance graph. I wonder what they want us to do. Time to cheat. So they want us to take the integral from 0 to 2 and then 2 to 5. Okay, fine. So, okay, to find the maximum distance of the particle at the time t, which is the endpoint, you can basically just take the integral from 0 to 5 of the velocity function. And then we can just do this in a graphing calculator, and then that should give us my distance at 5. I don't really want to type this in here, but I guess I will. So let's go to the integral calculator, and then go from 0 to 5, and then this is why I didn't want to. I don't want to type this in. So we have 2x squared minus 4x divided by x squared minus 2x plus 2. And this is variable of x. Okay, 1.55. So this is the distance at 5 seconds. And then we need to, I guess, calculate the distance at 2 seconds, just in case the distance at 2 seconds is larger. So you do the exact same thing, and then you just compare which one's bigger. And I think the answer key says oh, they actually want which distance. So when you take the integral of this, you're going to get negative 2.88. And then, of course, the maximum distance doesn't really matter if it's negative or not, because that just means like to the left or to the right. So I guess this one is the biggest one. Yeah. It's kind of a weird question. Okay, I'm not copying the last one because that's no longer in the curriculum. So here we have some function, and then you have x-intercepts at 0 right here, and then p, sure. The maximum's right here. And then we also have a point of inflection right here. So write down the coordinates of A. So the coordinates of A are where there's a maximum. So we can find the x value by taking the derivative, setting it equal to 0, and then solving for x. And then they want the full coordinates, so after that you plug the x value back into the original function to calculate the y value. So here we go. Actually, we don't even need to write this out. Calculator can do this for us. So clear it out. So we're gonna go to n derivative, and then our variable is x, and then we're gonna type in our function. So negative 0.5 x to the power of 4 plus 3 x to the power of 2 what is this next? Plus 2x. And we want to evaluate this. Oh shoot, what am I doing? Can't do any of this. We gotta do it the long way. Okay, never mind. Take the derivative. Because we're not evaluating, we're solving. Oh man. So there's my derivative, and then I want to find out when this is 0. So I'm going to go Desmos. Just because, you know, it's a touch faster. So as you can see, it's equal to 0 in the origin, but we want to find out this value, where it's also equal to 0. And that corresponds with this one, 1.732. So if x is 1.732, so I'll shorten it to 3 sig figs, then we calculate y. So what we're going to do is plug in 1.73 as x in our original function. So negative 0.5, 1.73 to the power of 4. Oh wait, did I type this in right? Yeah, I did, okay. Plus 3 times 1.73 to the power of 2 plus I don't think I typed this in right. That was supposed to be plus 2. Yeah. So change that to 1.88. Man, I wish you guys could use Desmos on your paper. Things would be a little bit more convenient, I feel. Okay, and then the y value should be this, 8.12. So that's the coordinates of A. And then write down the change of f at A. Well, the change of f is 0. Because the change of f is the derivative, and the derivative is 0 at A. Why is that worth 3 marks? Oh, that's... Okay, it's 3 marks for the coordinates and then the rate of change, but the rate of change is 0. Then we find the coordinates of B. So what I'm going to do is I'm going to change these to x's. I'm going to call this f of x. Now, B is an inflection point. So that means that the second derivative is equal to 0. So we can take the second derivative, set it equal to 0, solve for the x, take the x value, put it back into the original function to get the coordinate of B. And then also we can find the rate of change, which is we take the x value we got, and then we plug it into the first derivative. So kind of a calculator heavy question. So take the second derivative, and you can do this by hand, it's not that bad, but here's the second derivative, and right there is where it's equal to 0. It's equal to 0 at an x value of 1. So it's 1 comma, and then we evaluate the function at 1, which is 4.5. And then to get the rate of change, we evaluate the derivative at 1. So change this to, I guess, f prime, and then it gets 6. And then that's it. So let's see if that's what they got. So 2.73, what even is that? Oh, find the value of p. Oops, I didn't even answer that question. I skipped this one. That's the x-intercept, right? Which you can just graph and solve. My bad. So there it is. 2.73. And then write down the coordinate of A. So 1.88, 8.12. That's what I got. And then the rate of change is 0, yeah. And then blah, 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 blah. So we have a coordinate of 1 and 4.5 and a rate of change of 6, which is what I have here. So that's good. It's not a bad question. I don't know. It's kind of easy. As long as you know what you're doing and you can use your calculator efficiently. Okay, what's this? We got a bearing question. Ship is sailing north. Okay. And then point D is 60 kilometers north of point C. Bearing E from A is this 55, this one. Blah, 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 whatever. All the info is up right here. So next up, we need to find the bearing from A to E. Bearing of A from E. So we're trying to figure out this bearing right now. This one. Now, this is just some basic geometry. I know that this angle, and actually, I'll use a different color. Hey RGPT, did you poop? Did you shower? Did you eat? Yeah, I don't know what's going on with chat. They're kind of quiet. computer's laggy today. So from basic geometry, those two are the same angle. They are supplementary. Call. You want to be part of the stream for a bit? Say no. The chat doesn't want it. You don't feel like typing? Why don't you just listen while you do stuff? You don't need to say anything. But anyways, this is supplementary, so 180 together. So this should be 46, which means that this is 46. Okay, I see how it is. And then we have this triangle, so we can figure out this angle. Because again, these three should be 180. This is 55, that's 46. I close my calculator. But 180 minus 55 minus 46 is 79. Damn, RGBT is getting timed out. / timeout. How long is your editing gonna take, RGBT? I'll give you 10 minutes. What is that? 600 seconds? Time you out at the worst time? My bad. But that's okay, you gotta focus on your editing. Just listen. You can just listen. And then finally we can get the bearing, the orange, because all three of these angles are 360 together. So 360 minus 46 minus 76, which is 238. Okay, with that, now we need to find the distance CE. So all of this stuff is kind of clogging up the picture. So I'm just gonna get rid of it now. So to find this length here, we have a sine law setup. So we're just gonna use sine law. So x over sine 55 is equal to 175 over sine 76. So solving for x, again, change your mode. This should be in degrees because this is a question in degrees. We're gonna have, what is it, 175 divided by sine 76 times sine 55. So there's x, 147.7, but I guess we round it to 148. I guess it's kilometers. And then from here we need to find dE, which is this distance that's not drawn. That goes from D to E. Let me get rid of x now. But we just use either cosine law or sine law on this non-right triangle right here. Because we just found out that this is 148, and we already know that this is 60, and we know that this is 134. So here's a cosine law setup now. So we just use cosine law to calculate dE. So that says I'm going to take 60 squared, I'm going to add 148 squared, subtract 2 times 60 times 148 cosine 134. And then I get this, and then I square root this. So I'm going to take it to the power of 0.5. So 194.5, which I guess rounds to 195. Okay, and then the ship is going to reach point D. Where is the ship even going? Okay, it goes from point A to point D. So it goes straight. So what does all this bearing have to do with this? It's going in a straight line. Whatever. And anyways, okay, when the ship reaches point D here, it changes direction and travels directly to the island, which is at point E, at 50 kilometers per hour. So it goes like straight up to D, and then it turns, and then it goes to E, like this. And then it travels at 50 kilometers per hour. At the same time as the ship changes direction, a boat starts traveling to the island from A point B. And we don't know what that point is. Point B lies on AC, so somewhere here. So here's C, and then here's A. So point B is somewhere here. What is this question? And is the closest point to the island. The ship and boat arrive at the island at the same time. Then we need to find the speed of the boat. Excuse me? Okay, hold on. What is this question? Okay, let's find out how long it takes for the first boat to get there, because it travels at 50 kilometers per hour, and we know the total distance that it travels. So let's do that first. Time. So it travels 175 plus 60 plus this distance, which we found here at 195. I really don't like this question. So 175, 60, 195. So it needs to travel 430 kilometers. It goes at a speed of 50 kilometers per hour, so I divide this by 50. So it takes 8.6 hours. Okay. Now, that is the same amount of time that the other boat takes, because it says here that they arrive at the same time. So I'm going to clear out this diagram. Because it's the shortest distance, we know that it's a direct perpendicular line from AC to E. So if we know the time, and we can definitely calculate this distance, I think, or there are ways to calculate this distance, then we just take the distance, divide by the time. Hold on. I feel like I don't want to erase this diagram just yet. Because we want to find out this thing. And then we can use this larger right triangle, because I know that this is 195. So the only thing I'm missing I want to find this angle. And I feel like I probably could, but oh, what am I talking about? Jeez, I don't need the larger angle or the larger triangle because I know CE is 148, so I'm going to use this right triangle, and that works out nicely because I know that this is 46 degrees. Yeah, I don't know. I googled relaxing video game music like normal because I know I'm allowed to play video game music on Twitch. Okay, let's find that distance then. Finally. So that's just regular trigonometry. Sine 46 is x over 148. So x is gonna be whatever that is. Not relaxing at all? Okay. What about this one? So 48 sine, oops, 148 sine 46. So there's my distance. And then I divide that by the time to get the speed, kilometers per hour. So 12.4. So blah, blah, blah. So speed. .4. And I feel like there's one more question left. Aha. Hey look, it's a probability whatever table that I taught you guys. You should be able to do this question now. For my students that are watching. You should at least be able to do this first part right here. Actually, you can do probably up to this part. So here we have a random variable x, and then here's a probability table. We know the expected value is 1.2, and then we need to find p and q. So we can get a system. These probabilities need to add up to 1, and then of course we also get a second formula or equation from the expected value. So let's do that. P plus 1/2 plus 3/10 plus q equals 1. In other words, p plus q, and then this thing is 5 over 10 plus 3 over 10, which is 8 over 10. And then I'm going to move it to the other side, so now it's subtract 8 over 10. So p over q should be 2 over 10. And then my expected value is 1.2. So this is nice because when I multiply 0 and p together, it's gone. And then I multiply these together and then I add them up. So I get 1/2 plus 3 over 5. Actually, I'm just going to write 6 over 10. Plus 3q equals 1.2. And since it's in decimals, I'm going to change this one to decimals too. So 2 over 10 is 0.2. Okay. And I know, okay, this is weird because I'm mixing decimals and fractions. So I guess I won't do that. I'm going to change these as well. So that's 0.5, and then 6 over 10 is 0.6. Okay, so from the expected value question, 3q is equal to 0.1. So q is equal to 0.1 divided by 3, which is 0.0 something something. Yeah, kind of an ugly one. I'm going to change it to a decimal, or I mean a fraction. So this is 1 over 30. So q is 1 over 30. And then I guess I'm going to change this one back into fractions. Whatever. So p plus 1 over 30 is 2 over 10. So p is 2 over 10 minus 1 over 30. So if you do the fraction math, that's 5 over 30, I think. Oh, did I check my answer for this one? I never did. Let me check my answer for this one. Stretch again. Okay, let me check my answer first. So 235, yeah. 146 kilometers. I got 148, so something's a little bit off. They use sine law though, and I use sine law. Whatever. And then cosine law, and then I get 193. Mine's gonna be a little bit off because you have to use part B, and my part B was a little off. And then the speed is 27 kilometers per hour, and mine's off again, probably because my answers are all off. But yeah. Okay, time to stretch. I don't know what to stretch right now. Okay. Tell me how close I am to touching my hands behind my back. Okay, never mind, I can touch them on this side. Just barely. But I'm pretty sure this side is not even close. This is as far as it gets. Very far? Yeah, how far? How far do you think that is? 3 inches? Yeesh. Yeah, I don't know what's up with my right arm being really inflexible like that. I guess I should work on it. Anyways, back to this one. So yeah, expected value, and then probability, we can get P and Q. And then it shifts over to a probability question. So you have a bag, and it contains blue and white marbles, and then there's at least 3 of each color. And then you're gonna take 3 marbles from the bag without the replacement. And then it says here, the number of blue marbles you draw is given by the random variable x. So now this represents the probability of drawing, 0 blue marbles, 1 blue marble, 2 blue marbles, or 3 blue marbles. So before we get going, I'm probably going to use these probabilities. So I'm just going to check and see if these are correct. So 1 over 30, I think I have that. And then 5 over 30, which they reduced to 1 over 6. So I think these are good. So I'm going to add them into the chart, actually. And then 5 over 30, I guess that reduces to 1 over 6. Okay, so what's the probability of drawing 3 blue marbles? Well, it's right here. So 1 over 30. Now, explain why the probability of drawing 3 white marbles is 1 out of 6. So 3 whites means that you have no blue. No blues means your random variable is 0. And of course, that probability is 1 over 6 from the table. Then it says, the bag contains a total of 10 marbles, of which W are white. Then we need to find W. Okay. So what's the best way to do this? Let's do it this way. 3 white marbles is 1/6. So that means that you need to draw a white marble in the beginning, so that's W out of 10. Then you need to draw a second white marble, so there's W minus 1 out of 9. And then you need to draw a third white marble, which is W minus 2 over 8. And you know that this is equal to 1/6. So from here, we can just solve this equation. So I'm going to do this graphically. And I'm going to use Desmos. So I have W over 10. Or actually, I'm going to change that to X. And then I'm going to multiply that by X minus 1 over 9. And then I'm going to multiply that by X minus 2 over 8. So here's my graph. It's a little hard to see. And then I want to find out when this is equal to 1/6. So I'm going to say y equal to 1/6. And as you can see, it is going to intersect at an x value of 6, which means that W is 6. And then from there, it switches to distribution, probably binomial distribution, which my class will learn next week. But anyways, okay. A game is played, you draw 3 marbles from a bag of 10. You get a prize if you win, if you draw 3 white marbles. So in other words, you win. Your probability of winning is 1 out of 6 because it's the same probability as drawing 3 white marbles. Okay. You play the game 9 times. Find the probability that you win twice. So this is a binomial distribution. We have 9 games and we are going to win twice. So easy peasy, we just go to our calculator and punch this all in. So go to distributions, go down to binomial PDF. We have 9 games, so those are our trials. Our probability is 1 out of 6 for each trial. And we have an x value of 2, because we want to win 2 of those games. Press paste, press enter, there you go. That's the probability. So 297. Okay, now Grant plays the game until he wins 2 prizes. Find the probability that he wins the second prize on the 8th attempt. So on the 8th one, he needs to win. So the probability of winning is 1 out of 6. So that means that from the 1st to the 7th game, he needs a 1 win. Because if he wins another time within the first 7 games, then that means that, well, the game ends. So he's not going to win on the 8th draw. So this is just another binomial theorem. It's just in this case, we want to find out the probability of him winning once in 7 games. So we're going to go back and redo our distribution. And now our trials are 7, and then we want to only win 1 game. So this is 0.391. Now we combine these probabilities together through multiplication. So times these together to get our full probability. So I'm going to take this and then divide it by 6, which is 0.651. And then I think that's the end of the paper. Man, I was talking shit about times 1, 2, but it ended up being pretty... Some questions were a little difficult. Oh, he's back. Okay, so let's see how this went. So I know that these two were good because we checked them earlier. And then this is 1 out of 30. This one's 1 out of 6. Yeah. Blah, 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 blah. W is 6. Yeah. And then we get 0.279, which I think I got right here, or 297. And then blah, 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 0.651. 0.651. Nice. So there you go. Overall, not bad. This one with the bearings could have been better. It's just this question was so weird, the way they worded it. But there you go. I'm gonna make a new section. I feel like I have too many pages in here. But I don't know, something's going on with my computer. It's a little laggy right now. Everyone's doing their TOK essays. So I hit up the after school homework club, and then your classmates were asking me if I believe in communism, because they brought up this whole ski trip thingy, fundraising dilemma, where imagine you're at a class and everyone had to fundraise to go on a ski trip, and then some people fundraised in excess and then some people didn't. And so the debate was, how do you split the money, the excess money? Because, like, do you give more to the people that raise the most? Do you split it evenly across the board? Is that fair to the people that didn't do as much fundraising to get the same amount of money as those that did more fundraising? Yeah. So equity versus equality. But anyways, so I emailed your TOK teacher because that's actually a math question. I literally have a grid that has a fake class with fake fundraising numbers and fake, like, costs of the trip, like ticket prices, ski rentals, and I sent it to her, and I was like, don't thank me, but I might have just planned tomorrow's lesson for you so that you guys can actually, like, crunch out some numbers. You're welcome. You're welcome. Oh, you had numbers? Okay, never mind. You're just too lazy to use them? Okay, no one mentioned to me that you had numbers. So now I look like a fool. Oh well. I'll just tell her, you guys lied to me. I just say, oh, I asked the kids if you gave them numbers, and then they said no. Okay, so because paper 2 is tomorrow, I'm gonna do 2 paper 2s for anyone that is watching this. And you know what is so surprising? I went to my YouTube channel because like I don't go there that often, because I go to Twitch and then I just say like, oh, upload today's stream, and then every once in a while I hit up YouTube, and then like I had like 5 comments on like across my videos, and they were like, wow, this is so useful, I'm watching this like 3 hours before my exam. So I'm gonna do a second one for all of those YouTube people that for some reason aren't following me on Twitch. Also, I'm gonna stream on Sunday, but I don't think I'm gonna stream next Thursday because I'm a little busy. Just a little busy next Thursday. Just as a warning. But I'll probably post that on my Discord too. Okay. Here we go from the beginning. Find f of 8. This is easy. We just plug in 8 into f. So 8 squared plus 2 times 8 plus 1. So this is 64 plus 16 plus 1, which is 81. No calculator even needed. Yeah, this is a freebie. Well, I mean, it is question 1, so you know. Next up, g of f of x. Oh, they're so nice. So we're plugging in f of x into g. So that just means I'm taking the function f, and then I'm plugging it in for the x variable in the g function. And then we might as well just simplify this a little bit. Minus 4. Wow, free. Very free. And then we need to solve when this is equal to 0. Is this a paper 1 or a paper 2? This is too easy. This is a paper 2. Okay, whatever. Solve this equal to 0. So now I take this and I equal it to 0. And I guess, okay, it's not factorable, I think. Is it? No, it's not factorable. So we can either use quadratic formula, which is kind of stupid, or we can graph it and then just find the zeros. So I'm going to graph this. And I'm going to save myself some time because it took me almost an hour and a half to do that first paper. But then I was kind of going slowly. So it's x squared plus 2x minus 4. So I have 2 solutions. One at negative 3.24 and one right here at 1.24. So 1.24, negative 3.24. And then hydrate. So easy marks. I'm choking on my water. But yeah, because I'm doing 2 papers, probably no fun tonight. No drawing, garlic phone, scribble. Okay, what's this? Got a function, it's got a minimum, find the coordinates of the minimum. So, well, I gotta finish this paper. And then by that time, it's gonna be like 2 hours and something. And I don't want to stay streaming for 3 hours. Yeah, no RG on call. See? Anyways, you can just graph this and get the coordinates. So that's what I'm gonna do. So 0.225 x to the power 3 minus 2.7x Okay, so here's our minimum. It's at 2 and negative 3.6. IB ruins all the fun. Okay, on the grid, sketch this graph, clearly indicating point A. So there's point A. And then it's gonna go through 0. That's why I do half? What do you mean half? Only half the paper? Oh, never mind. I see what you mean. And then somewhere here, we also have a maximum. So this will go No, the smartest people are the ones that decided not to take IB because it wasn't worth it. Oh, your statement also includes those people? So here you go. And then sketch the tangent of the graph. So because it's a minimum, the tangent's horizontal. So just draw a horizontal line. And wobbly. This is not that great, but whatever. It does its purpose, I'm sure. Oh, I should check my answers for the YouTube again, so that they're not waiting till the end of the video. So 81, that was easy. Plugging it in, you got -4. Taking the graph, getting the x-intercepts, negative 1.24, negative 3.24, so that looks good. And then here's their drawing. Uh-oh. I think I'm gonna lose marks for this. So they said specifically draw it from -3 to 3. So if you don't do that, you might lose some marks. So let me just erase this. There you go. Oof. Is that good or bad? Is math gonna be a first semester? We don't even know anything about next year. Okay, so here's the graph. It's a little bit inaccurate, as you can see. So try to make it a little bit more accurate when you're graphing it. Ew, 7:30 to 5? That's disgusting. You're there for more often than like the teachers are. That's absolutely disgusting. Those are like the early morning and then the late evenings. Those are like the ghost hours. That's when the ghosts come out in the school and like the weird noises start happening around the school. I wouldn't want to be in the school at those times. Okay, what's this? Circle. Divided into 5 equal sectors. Okay. So that means that the central angle is 2 pi over 5. And then what does it want? Write down the exact value of theta. Oh, I did that accidentally. Nice. Then the area of the sector is 20 pi. So then we can find the value of r. So the area of the sector is 20 pi. From the formula side of things, that's 1/2 times theta times r squared. And then this is equal to 20 pi. Okay, so there's pi's on both sides, so they cancel out. These 2's cancel out. So in other words, r is equal to 5 times 20. Kaylin, no. Thanks for the follow. So this is r squared, which means that you take the square root, and then r is 10. And then we find AB. So now that we know the radius is 10, we have this triangle, and we can just use cosine law on it to find AB, the line AB. So I'm going to save myself some time, and I'm just going to say cos law with 10, 10, and then the central angle of 2 pi over 5. So as long as you put it in, you should get it right. Save myself some time. I went through a full cos law question already. Am I doing a full paper? I would like to finish this paper, but I'm going to start skipping steps and not completing questions. Okay, you got a graph, then you got another graph, and then they are going to intersect in 2 sections, or 2 places, and then you need to find these values. So you need to have the function of g in terms of x if you want to graph it in a GDC. So what it says is you take f of x and you multiply it by -3, and then you add 1. So in other words, this is -3 bracket x e to the negative x plus 1. So now you can just graph this, calculate the intersections. So I'm going to do that on Desmos. So f of x is x times e to the power of x. And the reason why I'm negative x, so you get this weird whatever. And then g of x, this is why I'm doing it on Desmos, because you can just type it as you see it. This is -3 f of x plus 1. So there it is. And you can see there's my 2 intersections. 3, 5, 7, and then 2, 1, 5. 3, 5, 7, 2, 1, 5. 3, 5, 7, 2, 1, 5. And then hence find the area enclosed by the graphs f and g. So if you look, f is on top of g in this little section here. So we're going to take the integral from 0.357 to 2.515 of f minus g. And this you can do in your GDC. I'm going to do it here. So integral from 0.357 to 215 of f of x minus g of x dx. So this little area enclosed is right here, 0.538. So let's see if that's correct. Oh yeah, and then I didn't check the previous question. So 2 pi over 5, yep. Radius is 10. See, use cosine law, you'll get some answer that I didn't do. And then 357, 215, take the integral. So you get 0.538, just like what we did. Okay. Let's see. We got some babies in Australia. When they're born, they have an average weight of 3.41, standard deviation of 0.57, and then we consider a baby to have low birth weight if it weighs less than a certain amount. Now, 5.3% of babies are considered to have a low birth weight, so find out what that weight is. So we have W right here, and this probability is 0.053. Because we know the mean and standard deviation, to calculate that upper boundary, W, we use an inverse normal. So we go to second distribute inverse normal. Our area is 0.5056. Standard deviation and mean. Just put this into the calculator. And then here you go. So 2.5 kilos. W is 2.5. Now, a newborn baby has a low birth weight, so we know it has a low birth weight. Then let's also find the probability that it weighs at least 2.5 kilos. So probability that the baby, I guess I'll call it X, is greater than 2.15. But this is conditional because we know that it's low weight. In other words, we also already know the baby is less than 2.5. So according to our formula, conditional probability formula, this is on the bottom, probability of it being less than 2.5. And then the intersection of these two, if you just think about how the numbers work, being greater than this but less than that, the intersection is literally being in between the two. Okay, now they already told us this in question A. That's 5.3%. To calculate the top, we just use a normal distribution in our calculator. So norm CDF, our lower boundary is 2.15. Our upper boundary is 2.5, and then 3.41 and 0.57. So the numerator is going to be this, 417. Okay, so divide this by, and here's your answer then. 786. And then I made it here. To the long questions. Wait, no, never mind. This isn't a long question. Okay, function. Oh, I'm gonna skip this question. It's not part of the curriculum anymore. Okay, moving on. Okay, probability. We got a jar. It's got 5 red discs, 10 blue discs, and then M amount of green discs. We take one at random and then we put it back. Oh, that's nice. And then we do this 4 times. So write the probability that the first disc is red. Well, that's 5 out of 15 plus M, which is the total amount of discs in the jar. Okay. Now X is going to be how many discs we will select. Find the smallest value of M for which the variance is going to be less than 0.06. So I don't know if this is part of the curriculum anymore, but the variance of a random variable, it's in your formula book. I think it's P, which is the probability, times 1 minus P, which is the complement. But you know what? Let me pull up a formula book just in case. Okay, I don't know if we do this anymore. I'm gonna check the answer key for that question. Is it in the box under? Oh, is there a box under? No. Anyways, okay. So I said 0.5. Is it in, oh, box under in the formula book? This one? It's not here, because this is HL stuff. There's a variance formula, but that's for the next section. So, anyways. Oh wait, no, never mind. I was right, or you're right. Sorry. This is because you're selecting 4. So in that formula book, I was just like, I don't know what N is, but you are selecting 4 discs. So 4. Okay. So essentially, the probability of selecting a red disc is this right here. So 1 minus this. So we should find out when this is equal to 0.6. And for this, you can, I guess, graph it. So 4 brackets 5 divided by 15 plus x, 1 minus this stuff. So here's our graph, but we're only really considering the positive part of things. And then where's 0.6? So right there. So when x is 12.2, it will be 0.6. Now, x represents m, and m is about how many green discs you have. So you can't have 12.2. We need to round it to the next number. So m is 13. Because once it's 13, you can see the y value is less than 0.6. Okay. This looks gross. But we've made it to the long questions. Okay, 10 students were surveyed. How long they spent browsing the internet. So if we add up all the students' times, we have 252. We have standard deviation of 5 hours and an average time of 27. So much stats. Anyways, find the mean number of hours. So we already know how much they all add up to, and we know that there's 10 students. So the mean number is 252 divided by 10, which is 25.2. Okay, then during the second week, students worked on a major project, and then they spent 5 more hours, each one of them, browsing the internet. So what's the mean? So the mean will also increase by 5 hours, so this goes to 30.2. The standard deviation, however, will stay the same, because they're still spread out the same amount. Then in week 3, each student spends 5% less time browsing than they did in week 1. So in other words, the median is now 95% of the original median. Likewise, the standard deviation is also 95% of the week 1 standard deviation. So we can just put those in here. These questions are easy so far. So 23.9. And 4.75. Oh, whoops, the median. Oh, whoops, I was working on the mean. Not paying attention. Uh-oh. I should read these questions. I just found the standard deviation. Let me finish this one. This is standard deviation. So that's 4.75. But it wants the new variance. So then I need to square this. So square this, 22.3 or 6. Okay. And then the median is 27, so I think I just do 95% of 27. So 25.65. So 25.7. I forget how median changes if you changed all the data. I'm a little curious. I'm just going to check that out. Oh, it is that. Okay, easy peasy then. And then again, during week 4, the survey is extended to all 200 students in the school. The results shown in the cumulative frequency graph on the next page. Find the number of students who spent between 25 and 30 hours. Man, this question's so long. Oh my god, okay. So, find the number of students who spent between 25 and 30. So 25 is here, which goes to 80. So someone remember that, 80. And then 30 goes up to here, which is 150. So 80 to 150, how many students is that? 70? Then given 10% of students spent more than k hours browsing the internet, find that value of k. So the top 10 students, well, there's 200, so 10% is 20. So from 180 to 20, these guys spent this much time or more. So 35 hours or more. Okay, it wasn't that bad, this question. It was just kind of so much words, but it was pretty easy. What the? Okay, so we have a particle, it has a velocity, it's split up into two different functions depending on what time it is. Here's the graph. Find the initial velocity of p. So when time is 0, I need to use this function, so I'm just going to plug in 0 here. So if I plug in 0, I'm just going to get 2. I guess I'll copy this first before I keep going. Now, p is at rest when the time is 1 and also at p, so here. Find the value at p. So this section from 0 to 1 is represented by this first one. So that means that from 1 all the way to 12, it's represented by this one. So if we want to find out this, which is that p value, I need to find the x-intercept of this graph. So time to graph and find my 0. 3 square root t, 4 over t squared. I'm not going to remember this, I think. Okay. 3 square root x plus 4 divided by x squared minus 7. So there it is. P is 5.23. Okay, when t is a certain value, the acceleration is going to be 0. Then we need to find the value of this time. So we need to take the derivative. So we will get 2 parts. We'll have -2, and then we're going to have this one. So because this one will never be 0, we don't need to worry about it, because we're trying to find out where the acceleration is 0. So we're going to take the derivative of this and then solve it for 0. So back in Desmos, because this is my cheater, I can, if I assign that as f, I can say graph f prime. So you can see right here we have the acceleration, which is the derivative of velocity, is 0 here. 1.953. If you, and then of course on an actual GDC, you would take the actual derivative itself and get an expression and then graph that instead. But like I said, I'm trying to speed this up because this is my second paper. Oh yeah, and then I should check my answers. So all of this is correct. And then 80, 50, so you subtract it, you get 70. K is 35, so that's good. And then let's continue this question. Hence, find the speed when t is equal to q. Oh, so this is the time, so 1.95. We just plug this into our function. So we would plug it into the second one. So I guess I'll go to decimals and do that. So what's f of 1.95? Negative 1.76. But it's suspiciously bolded speed. So I guess they don't necessarily care about the direction you're going. So maybe we'll just ignore the negative. Okay. Then we need to find the total distance traveled between 1 and P. Okay. So if you look at the graph, from between 1 and P, and remember P is 1.95 or something, so right here, the whole graph is underneath. So what I can do is I can just do an integral from 1 to 1.95 of my function. And then I just ignore the negative because the whole thing is underneath the x-axis. So 126. And then hence or otherwise find the displacement from A when t equals p. A is, what is A? The beginning, right? Okay. So if you look at the graph, this graph, the displacement is going to be taking this integral, which is positive, and then you just literally add it with this integral, which is negative. Okay. So we need to find this integral. You can take the actual integral of the first function from 0 to 1, but notice that it's linear. So it actually is a straight line here in this orange section. So that's a triangle. So we don't need calculus to calculate that area. We know that this is 1, and then you can see that the x-intercept, or sorry, y-intercept would be 2. So this has a height of 2. And then base times height divided by 2 is the area, so this has an area of 1. So the displacement is 1 minus the area we found in part I, so negative 0.26. So let's see, you get 2, you get 5.22, 5.23, sure, 1.95, 1.76, and then find the total distance traveled between 1 and P. What? Oh, 4.4. Why do I have 1.26? I'm here. Oh my gosh. I messed up. I was using Q, but then they want you to do P, which is 5 point something. My bad. I need to read. This is P. P was the 5.23. So from 1 to 5.23, which is somewhere over here, you are going to have a little piece that's positive and then all of this negative. So if you want to find total distance, we're going to do the integral from 1 to 5.23 of the absolute value of the function. So you should get 4.45. Because we don't care about negatives and positives, we just take the absolute value and then add those two little areas together. So that you can also do in your graphing calculator, all of this. And then I think that's the right answer, 4.45. And then to get the displacement, this is the integral from 0 to 5.23, which we're going to split into the integral from 0 to 1, and then from 1 to 5.23. But this was that triangle, which had an area of 1, and then we just need to calculate this part here. So with that, we don't need the absolute value brackets. So that's negative 4.45. So minus 4.45, which is negative 3.45. So this should be right. I think these were the numbers I saw in the answer key. Yeah. Yeesh. I need to read the questions more carefully. Okay, and then I think, is this the final one? Nice. We're going to end it off with a trig graph question. And then drawing. I'm already 2 hours past. Okay, so we have a sine wave. At least it wants it to be sine. Here's your minimums and maximums. So right there and right here. Is math over? Define over. Okay, so we're at 5 to 17, right? Which is right here. Okay, so my personal preference is to just find everything out before the question even asks for it. So we have from 5 to 17. So that's a total thingy of 12. Which means that we have an amplitude of 6. Total distance of 12. Which means that split it in half, we have an amplitude of 6. That means that my midline is going to be right here. Well, you can even see it because it started right there at 11. And then because it takes 6, let's say hours, I don't know what X represents, to go from minimum to maximum, then your period is 12. So your B value is going to be 2 pi over 12, which is pi over 6. Now, that means that C is the midline, which is 11. We already showed that B is pi over 6, and then find the value of A. A is related to the amplitude, the numerical value is 6, but we want a sine graph, and it does start in the middle, but then it goes down, and then it goes up, which is kind of upside down. So A is -6. And then, let's see, the graph of G is going to be F, and then we shift it to, we do a phase shift, left or right, K. Now the new maximum point has this coordinate, 11.5 and 17. So this maximum here goes from 9 to whatever it was, 11 point something. %. Why is it negative? Because we want a sine graph. And sine graphs need to, if they don't have a phase shift, when they're on the y-axis, they need to go up, then down. But this one goes down, then up. So that means that your A value is a negative because you have a vertical reflection. .5. So we've moved it from 9 to 11.5, which is 2.5 spaces. So K is 2.5. Then your function G is -6 sine pi over whatever this was, pi over 6. And then you need a second pair of brackets, and then it's x minus 2.5, that's the transformation we just found out, plus 11. Yeah, that's how you get the number 6, but then you also need to decide whether or not it's positive or negative, and that just depends on the shape of the graph. So I think that's G. And then the graph G changes from concave up to concave down when x is W. In other words, we have an inflection point here. So we're going to take the second derivative of G, and then we're going to solve it equaling 0. So you can do that yourself. It's not that hard to take two derivatives of this. It's kind of a pain in the butt, so I'm just gonna do it right here. So as you can see, there's my graph. It has the right maximum. Oh, yeah. And then I'm gonna call this G. And then let's look at what the second derivative of G looks like. And then what's my domain? From 0 to 12. So let's look at this from 0 to 12. Now, as you can see, there's two places where our second derivative is 0 because there's two inflection points. The one that we want is where it goes from concave up to concave down. So concave up is like this, and then concave down is like that. So from concave up to concave down is this one, this inflection point. Yeah, it's pretty useful, Desmos. So there you go. This is the inflection point we want, 8.5. Very useful. So dubs is 8.5. Then hence or otherwise, find the maximum positive rate of change of g. So we want the maximum rate of change of g. So the rate of change of g is g prime, but we want the maximum of this. So there's two ways to do this. You do have a GDC, so you can just graph g prime and then look at the maximum. I'm almost done though. This is the last question. Or, because we already have the second derivative here, we can look for, these are the critical points. So we can optimize this using calculus, right? The maximum of the first derivative is where the second derivative is going to be 0, usually. So there's two, and then we just need to decide which one is the one that has a maximum, which is this one here, because we have positive and then negative. So by first derivative test, 8.5 is the maximum. So if W is 8.5, then to calculate the actual maximum rate of change, we plug this in to G prime of W, which is 8.5, G prime of 8.5. So again, I'm cheating a little bit. I can just calculate this in Desmos. G prime of 8.5 is 3.14159. Oh, it's pi. That's cute. Wow. Amazing. So let's check if I got this right. And then maybe we'll do one round. Only because I want to shower, but the shower is currently being used. So I can afford to wait. Okay, so we got 11. We got pi over 6. We got negative 6. I got 2.5. I got this function. W is 8.5. Maximum rate of change is pi. So there you go. I think that is the end of this one. So there's 2 paper 2s in a row. I hope that for those of you that are using this to study for tomorrow's paper 2 exam that you learned something. And I guess fine, we'll go to Gartic phone again. I'll be pizza. No, I don't want to be pizza. I'll be pineapple head. Okay, and then let's do fast drawing and then writing only at the beginning and the end. Copy. Okay, I don't even know who's watching that's willing to play, so I'm gonna post that. Feel free to join in. I'm gonna close up these windows. There's Serpent. There's two Quolke. Anyone else? You guys want to play Gartic phone and I only have 2 other people besides me? I guess I'll post it on my Discord. Oh, someone posted food pic. Oh, nice food. Gonna give that heart eyes. Then I'm gonna post Gartic phone for others to join in. Is that it? I only have 2 other people? That's kind of sad. Campersan and RGPT are chatting in my Discord, but that's fine. Milky You, come play. Oh, you found it? Good for you. Come join, come join. 1 round, just 1 round. Maybe 2, depends on how long my washroom's being taken. Vincent, are you in yet? I have a strawberry, but I think that's Milky You. It was at home? Then how did you not know where it was if it was at home this whole time? Is this you? Are you Strawberry, Vincent? I thought that was Milky You. Are you too Quoque? Are we gonna start or not? Am I still waiting for you? So are we good or what? Vincent, you're in, right? You're this too Quoque guy, right? Okay. What's wrong? Actually, I'm not gonna ask that because I know what's wrong with furries. Furries are weird. Okay, me getting my math test back that I thought was easy, but no. I already don't know what this is. I thought I chose fast time. This is pretty slow. What? It's already over? Duck on my head. Is that a duck? I don't think that's a duck. Okay, I wanted to see what an Egyptian man at Wendy's looks like. This is so bad. Happy man with coffee? Me getting my math test back and I thought it was easy, but no. So I drew this. I'm not using a stylus, I'm using my mouse. When you think you got an A but you got an F, loser. That's close enough. History teacher can't read students' writing and rips up test. Oh, that's what it is. Man ripping voting apper. Rubber ducky. Oh, it was a duck. Okay. What do you mean you didn't have time? There's so much time. Nice. Duck on my head. It worked out. Okay, we're gonna keep going until my washroom's free. Running away from angry mob of May 4th protester? Huh? Oops. How am I supposed to draw a May 4th protester? Huh? I don't remember this. You who did this? Because whoever drew the one that I saw, you had like one letter. Oh, it was V. Oops. LOL. What even is this? What is this? Crying face emoji, but brown banana. Oops. Okay, I wanted a fat tiger on the beach. What even is this? Okay, not bad. Red cat? Why would you say red cat? That's very clearly a tiger. Okay, look how... See, I didn't know what to draw here. So I drew like this. Oh my god, your drawings are so bad. I run away from school. This looks like a piece of green corn. You didn't even bother to make it blue. I'm using my mouse right now too. Oh, painter's easel falls in the water. That's what that blue thing is. I changed it to an A though. Bob Ross spills painting. Oh, that's kind of close. League of Legends Bronze 4. Oh, is that what that is? I thought, you know, the crying face emoji, like the laughing one? But then it was like some weird brown banana version. The amount of detail that was lost. Uh-oh, shoot. I forgot his name. Oh, God. What is that guy's name? I'm so bad. Okay. Okay, this is the last round. Because I hear... I hear the washroom opening up. Shoot, I forgot what this looks like. Okay. Why is there so much time on this one? Thanks, RGBT. You advertise. Huh? What? What am I see? What am I looking at? I forgot his name. What's that aardvark guy's name? What? Baker? Beaker? Oh, Arthur. Yeah, Arthur. Baker head guy? What is this supposed to say? I forgot his name. I didn't forget him. I literally remembered his sister's name. I was like Dee Dee, but I couldn't remember his name. Me failing at Gardic phone because I can't draw. What is this symbol? What does this even mean? Anyways, I thought this was like Bitcoin symbol. Oh, that's IB symbol. Client airs concerns about their love life to the therapist. Oh, that's what that is. In love with sad mouth nerd holding pencil. Okay, doggy eat rice, yummy. So at first I was gonna draw that, and then I was like, how do I symbolize that that's rice? So I had to draw this Asian stereotype. Person with slice of cheese on head? No, that's rice hat. But you got the why would he eat dog poo? Because look, imagine this is gone, you would just think that this is dog food. So first I added chopsticks, but then I felt like that wasn't enough. I had to draw a person, an Asian person. Then you go, okay, maybe that's rice. Then the dog, you can say eats the rice. But whatever. Okay, like I said, the washroom's free, so I'm gonna head off. Have a good night. If you're studying for a test tomorrow, good luck. I will be back on Sunday, where I'm pretty sure I'm gonna go over the 2 IB exams, SL exams. So stay tuned for that you just wrote today and tomorrow. Goodbye, goodbye, goodbye.